So you can just treat like this is a resistor. It's a coil. So for equivalent circuit is what we are trying to do. Okay, this is V, this is R1, this is L1. Another circuit. It will help us to think. So there is a mutual inductance between them. So the moment you close switch, don't bother. The moment you close switch, here a current will flow. We know growth of current here. And the current will increase. And finally, how much of current will be? V by R1. V by R1 will be the final current, steady state current. So what is that current? Is a varying current, no? So due to varying current here, because of mutual inductance, a flux linking this loop will change. So an EMF will be induced. Here also, RL circuit, current will flow. So due to flow of current, there should be flow of charge. That charge is given Q naught, total charge. By the time current from zero, it becomes maximum current here. The charge here, it will flow this one. Once current constant, tell me what happens here? Though there's a mutual inductance, the flux linking the loop will remain constant. If you can understand, it'll be easy. Because say like a first what happened, at any instant of time, a varying current, flux linking this loop will change. So there'll be flow of current. At steady state, what will be the current in this loop? Constant. Flux linking second loop, constant. So what is the EMF induced will be zero. So definitely I think for finite amount of time, better say, charge will flow. That is what Q naught is telling. What is M is asking. We have to, I think, interlink here. You can take any approach. You can take any approach. Previous problem, what I did, I think that is what you have to apply here. There was a current flowing through a wire. Now a current, it was a function of time. Here it is varying current. The similar approach here. Okay, now I think I explained. I can't write so many equations for that one. So at any time t, so at steady state, at t equal to infinity, loop one, I'll call it. Loop two, at steady state. In loop one. So what is the current that will flow? Let it be I naught one, I infinity. Let me write symbol. Capital letter. It is enough. V by R1. Yeah, let me write here. V only, no, it is. Yeah. Okay, this is the information we have, and at any time t. At time t, current in both loops vary with time. So therefore, what is the source? What is the EMF generated in this due to mutual inductance? So shall we write here, no? M di1 by dt should be equal to L1 di2 by dt plus I2R. What is M di1 by dt? That will behave like a source. So this is the initial at any time t. I'll draw the circuit at least so that you'll understand what I am actually trying to explain. From where this source is, I am bringing, this is V, and here a variable current flows. Here I2. So from what is this? This is what? M di1 by dt. Fine. So or E12 or EM, anything. Yeah, or okay, let me write EM. And what is that EM is? This one. EMF generated in loop 2 due to mutual inductance. Okay, let me proceed with the mathematics here. M di1 equal to L1 di2 plus R2 I2 dt. I'll integrate. What is the final current? At t equals 0, this is what at t equals 0, no? At any time t. Finally, after long time, how much of current will be? I1 infinity. What about current in second loop? Anybody wants to answer? After long time, at t equal to infinity. Say we should have crystal clear ideas. That's all here. Nothing is there. Here I'm this what flows. Here I replaced the cell. This is what at t equal to infinity. Hope everyone understood. So therefore I'm writing limit 0. So what should be the current here? I2 is equal to, so this should be the limit should be infinity. We'll agree the limits 0, 0, why? Because no current will flow, no, finally. Because flux linking that remains constant, flux linking second loop remains constant. Loop 2, loop 1. Yeah, fine. Okay, let's get into M I1 infinity. This will be 0. R2. What is I2 dt? Is what I should call the charge, no? Q naught. So what is I1 infinity? So V by R1. So Q naught equal to MV by R1 R2. Q naught. Okay, we have to calculate M, no? M is equal to R1 R2 Q naught by V. A very nice question. Student has to. The limits is very important. This limits is what the main idea of the problem. We'll have one more problem similar to this. Mutual inductance